Okay, good morning. I recently gave this paper for my Year 13 students who are doing linear Edexcel physics in the summer. And I use the International A level to go through the content that we just covered, because the modular exam only concentrates on what you've covered in Year 13. So if you look at what you covered in Year 13, this term you should have covered further mechanics, electric and magnetic fields, and particle physics. So they'll be the same in linear as in modular. So the content is 99% the same. So if you just want to concentrate on your Year 13 content, this is a good practice. So we've used quite a few of the international papers as getting ready for the mocks in January, where they'll do a linear paper. So the linear paper will also include topics from Year 12, mainly on electricity and mechanics. So these two topics, together with the Unit 4 content, become Advanced Physics 1. So Advanced 1 in linear is a bigger exam than the Unit 4 content. Okay, so I hope that you find this useful. So whether you're doing linear or you're doing modular, I hope you make use of this walkthrough. Okay, so both the linear and the modular start off with multiple choice questions, and both are 1 hour and 45 minutes long. Okay, so the first question is always an easy question, and in this case they're talking about isotope, an isotope of astatine, and they're giving you the proton number and the nucleon number. So remember, nucleons are protons and neutrons. Yeah, they're also often given the symbols A and Z. So Z is the charged number, and it's the same as GCSE knowledge, so there's nothing new here, and all you've got to realize is the neutrons is the A number minus the Z number, or the mass number minus the atomic number, so depending on whether you study chemistry or not. Okay, so basically the protons is the smaller number, so it must be B or D, and the neutron number is obviously not 213, because that includes the protons, so it's 213 minus the 85, so presumably that does equal 128. So the first question is GCSE level, nice entry question for your exam. And here you have a capacitor being charged up, yeah, and normally, I think normally you put Q, charge, on the y-axis. So don't get confused when they change axes around. They're just trying to see if you can understand what's happening. So the graph of potential difference against charge is shown. Which of the following is the capacitance? And I think that's why they've done it this way, because capacitance, if you look at your formula sheet, is charge to voltage ratio. Yeah. So it's coulombs per volt, which we call a farad. Okay. So if you look at your formula sheet, they want you to know which one gives you the capacitance. But if it's charge to voltage, then you need to reverse the symbols. So it's going to be 1 over the gradient. So the answer is the inverse of the gradient of the line. If you see the others, you will see why they're wrong. Okay? So I think that's self-explanatory. Question 3. A proton is in a vacuum at a distance r from the proton. The electric field strength due to the proton is given in newtons per coulomb. Okay, now if you know electric field strength is a constant times the size of the charge divided by the distance squared, and where K is equal to the permittivity according to the following relationship. They give you both K and epsilon naught in your data sheet. Okay, so in the data sheet they'll tell you that epsilon naught is 8.85 times 10 to the minus 12, whatever units they are. Okay, you don't need to worry about that. Which of the following gives the distance? So you've got to change the subject to make r the Subject is the equation, so obviously you can just go to r squared first of all, and then square root whatever is on the other side. I always use k, but in the answer they've substituted k for 1 over 4 pi epsilon naught. So basically this is k, 1 over 4 pi epsilon naught. So it's q at the top. So q is 1.6 times 10 to the minus 19. So it's going to have to be A or C. And then you want 1 for, you want r squared at the, you want kq at the top, and you want 4 pi epsilon naught. Oh yes, you need the square root. So C hasn't got the square root. It's trying to work out what was missing here. This one's got no square root, so that would be r squared. This one would be r squared, and this one would be equal to r, because it has the square root sign. So I was confusing myself there. Yeah, so the square root sign is what we're looking for as a differentiation between A and C. Okay? And then in the upper atmosphere, it says high energy cosmic rays collide with molecules in air to produce muons. Okay, the average speed of these muons is v, yeah, but the average lifetime of these muons is greater than the average lifetimes of stationary muons. So they want you to know about the relativistic effects of particles moving close to the speed of light. And this is just a knowledge question. So this shouldn't take you long. If you know it, which of the following gives the reason for this increase in lifetime? Is that V is approximately equal to C. It's not equal to C. It's not greater than C, so that's wrong. It's not equal to C. It can't be equal to C if it has mass. So it's approximately equal to C, or in the same order, and it's not much lower. If it's much lower, the lifetime would not increase. So the answer should be C. By the way, the multiple choice answers from the exam board are also included in this run through. All right, so in the large angle alpha scattering, so that's Rutherford's experiment. You need to know this. It's a very, very common question. It probably comes up each year. Alpha particles were directed at a thin foil. They used a gold foil. If you remember, the alpha particles were then detected at 4 different positions: W, X, Y, and Z, or Z, yes, as shown, where were most of the alpha particles detected. So they want to see if you know the observations. And this is, again, just a knowledge question, so nice and easy. Most goes straight through, okay? So if most goes straight through, it should be position Y. And then I've put the rest of the knowledge, the observations that they observed, which was some are deflected through small angles, very, very few are rebounded. Very few rebound, okay? All right, so I hope that makes sense. 5 questions done. So each multiple choice question should take you less than a minute, or a minute at most, and they get more difficult as you go from number 1 to 10. Okay, question 6. In an electron gun, the current heats a metal filament to release electrons. What's this called? Again, it's just a knowledge question. Very, very common multiple choice question in both linear and modular, and it's called thermionic emission. So they want you to just know that, okay? If you look at the other answers, it's a nice gift of a mark. Question 7, electron and a positron collide and annihilate, producing 2 photons. Remember, it's always going to be 2 or more photons. So you're going to get each of the annihilated particles changing its energy by E equals mc squared to 2 photons. Yes, symbol for a photon is gamma. Which of the following energy in joules will be one of these photons? Which of the following is the energy in joules of one of these photons? If 2 electron masses, so the mass total is 2 masses of electrons going into the E equals mc squared equation. Yeah, so if you use that equation, then half the energy would be 2 mc squared over 2. So each photon will just receive mc squared. Okay, so the answer should be A. Okay, so a common mistake would be if you doubled up and assumed that it all went into photons, but they want for each photon. Yeah, so one of these photons will receive one of the masses, the other photon will receive the equivalent of one of the other mass. So two masses make two photons, so you can just basically say the mass of one goes to the other. Of course, these annihilating particles will also have some kinetic energy in reality, yeah, and they have not included that in this question, okay? And here are the multiple choice answers from the exam board, so you can take a look and stop the video if you wish to. That's the first 8. Have we done the first 8 or the first 7? Okay, if the 8 it might be on the next page, okay? Yeah, number 8 is on the next page. In high energy collisions, electrons are used to investigate the structure of nucleons. Yes. Which of the following is the reason why the electrons need a very high energy? So this is by a process of elimination. You can see they're ridiculous, some of the answers. So the electron collisions between electrons and nucleons are elastic. Well, if they're elastic, they wouldn't be able to penetrate. It means they bounce off each other. If they bounce off each other, it's not going to tell us very much about the structure of nucleons. You've got to basically penetrate them. The normal answer to this question is you need high energy electrons to have high momentum to get the de Broglie wavelength to be small enough. And here they've talked about the opposite of that, to have a large wavelength. A large wavelength would mean it won't penetrate. We need very small wavelengths in the order of the size of the nucleus. So the quark is knocked out of the nucleon. Well, that would be nice if they could, but quarks cannot exist alone. Quarks only exist inside baryons or mesons. So by process of elimination, the answer must be the only one left, so that new particles are created. Okay. I'm not sure that's the reason why they do it, but anyway, the other three must be wrong, so you've got to go for question A. I think this is a slightly misleading question in that respect. Okay, but you've got to just think on your feet in the exam. There's no right and wrong about how to work out the answers. Process of elimination is a common method. And here's number 9, nuclear fission. Yeah, we know that from GCSE, that it splits into two nuclei, daughter nuclei they're called. So this is GCSE knowledge. And then several spare neutrons in the fission process. S and T have the same kinetic energy, they say, but the nucleus T has twice the mass of nucleus S, and they want you to work out the ratio of T, momentum of T, to the momentum of S. That's what they want you to use your A-level further mechanics knowledge. You should always try to use this equation. It's a shortcut. It's where it links, instead of kinetic energy equals half mv squared, they're linking kinetic energy to momentum squared. Okay? And you should be able to work out where that comes from. So that means if we want to know the momentum, we need to make momentum the subject of the equation, because we know the kinetic energies are equal. So if we do two equations, it will be the square root of 2 EKM. If the P of S is 2 EKM, yes, and the P of T, remember P stands for momentum, will then be twice the mass, so 2 EK times 2M, where M is the mass. So that's why it's 2 times 2 in front of EKM. So the ratio of PT to PS, you've got to put these into this equation. Yeah, and when you put those two, one over the other, PT over PS, you get 4 EKM at the top, square rooted, and 2 EKM at the bottom, also square rooted. The EKM, I'm going to do that in red. The EKMs cancel, so you've got a square root of 4 over a square root of 2. which is the same as the square root of 2. So we're looking for the answer C. Okay? And finally, question 10 is about circular motion. So a model aeroplane is moving at a constant speed in a horizontal circle. F and G are given, are two positions of the plane a short time apart. The velocity Vf is here, and the velocity Vg is there, as shown in the diagram. As the model aeroplane moves from F to G, the change in velocity is delta V, and they mean vector change because the speed hasn't changed. Remember, the speed hasn't changed, but the velocity has changed because it's a vector. The direction is constantly changing in circular motion. So, which of the following gives a correct vector diagram for this situation? Well, we're looking for, V, final velocity, Vg, there's a final velocity at G, minus Vf. So if we want to have Vg minus Vf, we want Vg in the normal direction, and we want Vf being in the negative direction. So we're looking for Vg in the positive direction, which is downward at an angle. So which ones have that? This one's going down, this one's going down, and this one's going down. And then we're looking for a negative Vf added to the Vg. So this one is a positive Vf, and this is Vf plus Vg. Can you see? So that's not a minus. This is the only one which has Vg minus Vf, which means we started there and we finished there. And you'll notice that the velocity between the two of them is headed to the center of the circle. If you take the midpoint of F and G, the velocity will be moving to the center of the circle. Let's draw that in. So between there and there, that vector addition will be in this direction. Yes? So that's Vg minus Vf will be that red arrow, which would be this. Let's draw that neatly. Okay, so that's the same as what I've drawn on the circle. So that's how you prove, and these are often longer questions in the exam where you've got to offer the proof and also prove that delta V is equal to V squared over R. And that's by using similar triangles. So you need to make sure you revise this question very thoroughly in case you get a 6-mark question on this. Okay, that's a 10 marks done. And there's the final 2 answers that I went through. Okay, so just like in the linear and the modular, after they've done the multiple choice, they go into short structured questions, starting with short questions and then getting longer and longer as you go through the paper. Okay. Some of my students prefer the modular approach, and some of them find the linear easier. The linear is less in-depth in that they have to cover a wider set of topics. So it just depends on what you're used to, which one you're used to. But definitely using the modular allows you to practice a far greater number of questions before your linear exam than if you just did the linear, because there's only 1 linear exam per year, whereas there are 3 module exams per year. Okay, so here you got a proton entering a magnetic field, and the magnetic field is coming out of the page as represented by the symbol, which is lots of dots, which I explain to my students as if you're seeing the point of a dart come towards you. If it was going away from you, it would be an X in a circle, which could be a current, or a series of X's would be a field. going into the page, because if you saw the back of a dart, you'd see an X. All right, so the proton's coming in from the left into the uniform field at a velocity v. Okay, so it says the proton then experiences a force according to Fleming's left-hand rule, and the force is given as 6.5 times 10 to the minus 13 newtons. They want you to calculate the speed of the proton, and they've given you the magnetic field strength as 0.52 Teslas, and because it's coming in at 90 degrees to the field, sine theta will be equal to 1, and they basically want to check that you know which equation to use. So these are little checks on your knowledge. Okay, so when you change the subject of the equation, it's going to be V equals F over BQ, where Q is the same as a charge of an electron, which is the charge of a proton. And you get the answer to 3 significant figures, and really you should change it to 2 significant figures, because the data provided in the question, both the bits of data there and there, are both 2 significant figures. Okay, and then it says draw on the diagram the path of the proton in the magnetic field. Well, if you work it out according to Fleming's left-hand rule, the proton is the same direction as the positive charge moving. So proton being positive is the same as conventional current. So the field is coming out of the page. So you put your first finger coming out of the page and the current going to the right. So this is the same direction as current. Yeah, made it into a diamond. So this is the same direction as current in a circuit. All right, so current is in that direction. If current is in that direction, your second finger should be placed to the left, your first finger coming out of the page, and your thumb will be pointing downwards. So it's going to create a centripetal force, which will cause it to turn in this direction. Okay? And that's the 2 marks that you get, and we'll have a look at the mark scheme in a minute to see what they're giving for the 2 marks. So there's the mark scheme. As long as you've curved the path, you get 1 mark, and if it's in the right direction, yes, in other words, the clockwise path, you'll get the 2nd mark. Okay, so that's question 11 done. So we're going to do 1 more question, then I'm going to take a break. A student investigates collisions using 3 spheres. The student rolled the sphere mass 0.035 kilograms into 2 stationary spheres, yes, each with a mass of 0.037 kilograms, so not identical. The initial momentum we know then is all due to the original velocity u of the first mass, so we know the initial momentum. So as long as you can show that you know how to calculate momentum, they'll probably give you 1 mark, even if you get the answer to the rest of the question wrong. So 3-mark question. During the collision, the rolling sphere was brought to rest, so it loses all of this momentum that we just shown you above, and the 2 stationary spheres begin to move apart at an angle theta, yes, and presumably if it hits them with equal impact, that the theta will be half on each side of the horizontal dotted line. So the principle of moments is what you've got to use. The sum of the momentum before, which was what we worked out up there, although I didn't calculate it, must be equal to the sum of the momentum afterwards of the 2 spheres. So the initial momentum, which is 0.03 times 0.35 times 0.40, must be equal to 2 lots of 0.37. Remember, they've got slightly different masses, times cos theta, because we're doing the conservation of momentum in the horizontal component. So we're looking at horizontal motion. Okay, remember, like in year 12, you could do projectiles by isolating horizontal motion from vertical motion. So then you're multiplying it by the velocity, 0.21, that's given to you. Both of them have the same velocity. That means the angle will be halved. So that means the angle for one of the horizontal components will be cos theta over 2. One will be positive theta over 2 to the horizontal, and one will be negative theta 2 to the horizontal if you count angles as positive and negative. But the size of the angle then can be worked out. Cos of theta 2 will be that, so theta 2 will be 25.7 degrees. So each side of the horizontal line will be theta over 2, and therefore the total theta, don't forget to add them, and it will be 51.4 to 3 significant figures. Yes, and again, you should really change it to 2 significant figures because the data provided is 2 significant figures throughout. Okay, and that's 3 marks. So we've done some further mechanics. We've done some, what was the question before? We've done some simple magnetism questions and all the multiple choice. Okay, there's the answer from the exam board. Okay, so if you find these videos useful, don't forget to like the video you watch to help other students see it, because it helps with the algorithm for YouTube. And the more students see it, the more subscribers we get, the more common this paper will be seen around the world. And they're free. So I make these videos to explain it for my own students, and everyone else gets it for free. So I do sometimes get comments asking for help with questions, and I do try to answer them, but unfortunately, as I work full-time, I can't always answer the questions if it's complicated. And remember, face-to-face is a lot easier, or on a video. I don't always have time to answer by text straight away. So I will eventually answer, but sometimes I miss them. And that's why there's a membership. So if you really want your questions answered, you can pay to become a member, and then your questions will be prioritized. Okay, so really only the video is free, and I do try to answer questions. So do comment if you wish to, or if you're confused about something. And maybe someone else can also answer. It doesn't have to be the teacher always who answers the questions. Okay, thanks for watching. Make sure you subscribe if you want to know when the second part is released. Bye for now.